Okay, going on to page 30. The volume of a pyramid is given by this formula, where B is the length of the base, A is the height to the top, and H is the height. Suppose a pyramid was partially completed and had this for the height, so our H is 100, our B is this, and our A is this. So I've put this into the formula. I don't know if our calculator is even going to be able to figure this here, but you would square that, you would multiply this, you would square that, add that all together, multiply it by 100, and then divide by 3. And the answer comes out to be 33,808,000,000. Well, maybe I have, no, I'm off a little bit here. Let's see. 033. All right, this is not billion, this is million. And then 0.33 feet cubed. Okay, yeah, I think that'll fit in your calculator. And this one is done in a similar way using the same formula. So the answer is on page 51. Let's go on. So we're having some applications of polynomials, and let's take a look at this and see what we can come up with. So after putting all of this carefully into a calculator, and you should try this as well, I come up with this, and this is what they have, and I rounded it off to 3 decimal places. So this is a probability that we'll be studying also later in the course. And this is out of 1. So if you have a 0.5 probability, that's like 50%. And this is like 68.7%. If you are 73, you'll live another 17 years. And for this second example, it's done exactly the same way. You're going to put 5 where the x is. And it turns out to be 95.3%, or given as a decimal is this. Okay, let's go on. Now, as we mentioned earlier, we're going to be starting to do factoring. And what they want us to do here is look at this and factor out the greatest common factor. And the way we do that is we put a parenthesis there. It's going to be a negative sign in the middle. Now, in terms of the number, what's the greatest common factor we can take out of a 3 and a 15? Well, we can take a 3 out. And here we have a y to the second and a y. In terms of the letter, what's the greatest power that we can take out of each term? And it's a y. So now we divide each of these by that, and here we're left with a y there, and here we're left with a 5. And if we distributed this, we get that, and that checks our answer out. Now over here, there is no common number factor, but here we have x to the 5th, x to the 4th, x to the 3rd. So we can take x to the 3rd out of each item. And we can put our signs in there already. So here, x to the 3rd divided into there is x to the 2nd. This is going to be a negative 5x, and this will be a negative 2. Now again, you check these by distributing. We have taken out the greatest common factor. As we continue here, we have 3 terms. Put in our signs. Now in terms of the number, 4, 16, 8, we can take a 4 out of each term, and the letter that we can take out of each term, x. So this will be x squared. This is going to be a 4x, and this will be a 2. Now the key to this, to be sure you've taken out the greatest common factor, is what you have left now in the parentheses. There's no more common factors there anymore. Okay, how about here? Parenthesis for 3 terms. This is a plus, this will be a negative. And we're looking at the numbers. Looks like we take a 5 out of each one, a 5x. So we're left with x squared here. We're just dividing 5x, 2. And if we distribute, and as we check it out, and there's no more common factors there. Now for example 5, we see here is a base here that we could substitute that base for x. So in a sense we have this. So what can we take out of each term here? Well, we can take an x out, and we're left then with 3 plus x squared. But what is x? Well, x is z minus 5 in parentheses, and then we have a 3 plus, and then in parentheses again, z minus 5. So often when you're using 2 sets of parentheses, you change this one to a bracket. And this is squared. Okay. So as we go on now to our trinomials, there is no common factor in each one. So we're going to try to think of what set of binomials did this trinomial come from. So we're going to basically undo the FOIL, and when we multiplied this term by this term to get this term, what do you think was here? Well, there's only the one possibility, x and x. Now here we have 32 for our last term. Now we multiplied this to get 32, but then we did our inners and outers to get the 4x. So we need to play around with this 32. What are some factors of 32? Well, 1 times 32, 2 times 16, and we have 4 times 8. Now, if I put a 4 and an 8 there, now notice my last sign is negative. So one of these has to be negative. But my middle term is a positive 4. If this is a positive 8, and this is a negative 4, when I FOIL this, I get this. So I've checked it using the FOIL, and I undid the FOIL through brainstorming to give me possible factors. Okay, let's do this one. Now the first thing you do is put it in standard form, and these are both in standard form. Descending powers of x. And can we take out any common factor? No. So we're starting off easy. So again, our first term here was probably an x times x to give us an x squared. Now what are the factors of 8 that add up to 6? Well, this one was easier. 2 and 4. And since this sign is positive and this sign is positive, these are both positive, and you FOIL this, and this checks. So in example 3, again, standard form, no common factors, 2 sets of parentheses, an H and an H. Now, factors of 25 have to equal a 10 here. That's easy, a 5 and a 5. And since this is positive, both of these must be negative. So when we FOIL, we get this. Now this example is often written, could be this way, but could also be written this way. So this is a binomial that we square, and when we FOIL it, we get this. Now here's a case where, as we look at this, this is what we call the difference of perfect squares. And in our lecture, we probably went over that if you have a plus b and a minus b, this is the sum, and this is the difference of the same terms, and the product of that, if we FOIL that, is a squared, our outers a negative ab, our inners a positive ab, and our last a negative b squared. And you'll notice our middle terms cancel out, so we end up with a squared minus b squared. This is the difference of perfect squares, is what we have here. So if we recognize we have the difference of perfect squares, this factors into this pattern that if you don't have this word written down, write it down here. These are conjugates. So the difference of perfect squares factors into their conjugates. So this is going to be m plus 11, m minus 11. Now you could have made this one negative and this one plus. Doesn't make a difference. So it's in standard form, no common factor. We put 2 sets of parentheses, and our first will be a times a. Now we're looking for factors of 18 that when we subtract them are 9. 7. Thinking ahead. It's a 9 and a 2. Now our 7 is negative, so our 9 here for our outers need to be negative. Our inners a positive 2, which gives us a negative 7a. Okay. So we're moving on to page 34. And now we should give you some background. The standard form of these expressions are ax squared plus bx plus c. Now the ones we've done previously, our a term was a 1. But now in these, we're looking at our a term, and it's not a 1. So as we write this out, 6x squared plus x minus 2. These get a tad more challenging because we're wondering now, what would our first items be to produce this? Is it, we know this is going to be an x and an x, but is this a 6 and a 1 or a 3 and a 2? Well, I kind of saw this as I looked at that because I have some experience with this, and I believe it's a 3 and a 2, because if I put my 2 here and my 1 there, this will be a 4, This will be a 3, and the difference of it is a positive 1. If this one is positive and this one is negative. And there I believe I've factored that properly. And some of this is trial and check. Or sometimes they say guess and check, or trial and error. We're trying things out, and then we FOIL it to check our work. Notice in the answer key they have this first and this over here. It doesn't make any difference. As long as you FOIL it and check, that is satisfactory. So as we look at this, is it in standard form? Yes. Is there a common factor we can take out of every term? And in this case, there is. We're going to take out a negative 2x out of every term. Now, what does that do? Well, it reverses all our signs. This now becomes positive. This will become negative. And this will become negative. 28. So now this intermediate step is absolutely necessary. So we write the 2x again, and then we factor our trinomial. Here it's a little easier to factor. X and x, factors of 28 that have a difference of 3. Well, a 7 and a 4. Our middle term is negative, so the 7 is negative, and this is positive. And again, in the answer key, they did it the other way, but doesn't make any difference. Okay, taking a look at number 3. Well, notice this is a perfect square, and so is this. But there's no common factor. It's in standard form. So I'm going to give it a shot. Now if I take the square root of 81, I get a 9. And this is a 1 and a 1. And my outers are 9x, my inners are 9x, but they both must be negative. There we go. And another way to write that, remember, is 9x minus 1, the quantity squared. But this is how they have it in our answer key. Looking at example 4 now, this is a perfect square. This is a perfect square. But this is the sum of perfect squares. We said if they were the difference of perfect squares, that would factor into their conjugates. But the sum of perfect squares, as we see it here, is what we call prime. It is not factorable. Now, later we're going to see we can do something with that, but not at this time. Okay, let's take a look at this one. 24x squared minus 6x minus 9. Is there a common factor? Yes, I can take a 3 out of each one here. So 3 times 8x squared minus 2x minus 3. And then I want to see if I can factor that a little bit. So I put the 3 out here, 2 sets of parentheses. Now as I look at these, remember I could put an 8x and an 1x there, but that's not usually the case, especially when these numbers are small. So I'll try here a 4x and a 2x. Now I want my middle term to be a -2. So if I put the 3 here, this is going to be a 6 and a 1 there. My outers are 4, my inners are 6. This looks like the arrangement. Now I need my middle term to be negative, so the 6 would have to be negative, and then this is positive. And if I FOIL that, it checks out. And again, the book has it the other way, but this way is good too. All right, we're just at 21 minutes, so we'll wind this up.